Section 10.1, exploring quadratic graphs. I need you to think back to our test. The word quadratic, where have we seen quadratic before? Something to do with 2. Okay, something to do with squared. Anything that's a quadratic is something that might be written in this form. Ax squared, and there's the quadratic part, plus b times x plus c. And a quadratic is something that's in the shape of a parabola. Okay, remember a parabola? When we hang, I think Sophia, we took your necklace, remember? And we hung that necklace, and so it's in the shape is called a parabola. Okay, and it kind of looks like this U shape down here. Okay, now, little review about this. The very bottom point of the parabola, where it's symmetrical on either side around Chris, is called the vertex. And that can either be a high point or a low point. If it's a high point, it's called the maximum. If it's a low point, the opposite of maximum would be called the minimum. So in this case, what would this parabola have? A minimum, okay? That would be a minimum. Now, little comparison here. When the parabola opens up, the vertex is a minimum. And that's the illustration that we have here. Now, if I come over here to the other side, I'm just going to draw a parabola that's the other shape. This parabola, hopefully it's obvious that it opens down. All right, that opens down. I'm going to put a dot up here at the top. What is that dot representing? The vertex. In this case, that vertex is a what? It's a maximum. Now, to tell you about this equation, this one is going to be a negative x squared. In other words, the number in front of the x is less than 0. See here it says a is less than 0. So if a is less than 0, the parabola opens down and the vertex is a maximum. That's a question that will be on the quiz very likely. I'll give you an equation and I'll just say, is it a maximum or a minimum for the vertex? That's a question that should take you about that long to answer. Now, try if you can to take this graph that we drew over here and draw a line, a dotted line, right down the middle of it. What's unique about that line that we draw right down the middle? What does it cut the parabola into? Half, exactly. And what about each side of the parabola? How do they compare to each other? Yeah, they're symmetrical. Okay, and that line is called the axis of symmetry. The axis of symmetry. And it's a line that cuts the parabola into 2 mirror images. All right? Notice that the axis goes through what special point? What is that point called again? The vertex. So that's just some terms to kind of walk us through what a parabola is and what the parts of a parabola are. All right, little review down here at the bottom. This is a review for you. Do not say the answer, please. This is a review of coordinate points. Write down the point, the coordinates of the vertex, and then tell me whether it's a max or a min. Go ahead. Don't say it. Just write down the point, and then tell me whether that point is a max or a min. Good? Good. Good. All right. Right to the point. That slide. Good. 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 All right. Most everyone's got it. The point is 2, 3. And it's a maximum. All right. Let's flip her over. On this back side, I'd like to talk about how we go about graphing a parabola accurately. The key is to be as accurate as possible. We're not just going to do a rough sketch. We're going to try to be literally as accurate as possible. So our first step is to try to find the vertex. In most cases, most of your vertexes today are going to be centered on the graph. So whenever we're going to do a graph of parabola today, we're going to try to make a table. And so the points I want you to try that are probably the easiest points are 0, 1, and 2. So I'm going to plug these points in, and I just put those at random. 1/2 times 0 squared, 1/2 times 1 squared, and 1/2 times 2 squared. Well, what's 1/2 times 0 squared? 0. So the first point is 0, 0. So we plot that point. 1/2 times 1 squared is 1/2, so that's the point. 1, 1/2, so plot that point. And then 1/2 times 2 squared. Do we square first or take the half first? Square first, so 2 squared is 4. 1/2 of 4 is 2. So that's the point 2, 2. Now one of our goals when we did lines was to plot enough points so that points went all the way to where? Over the edge of the graph? We're not really at the edge of the graph. So I probably need to plug one more point in. Do you want to plug in 3, 4, or 5? Keep it easy. Plug in 3. 1/2 of 3 squared. 3 squared is how much? 1/2 of 9? 4.5. So 3, 4.5. I'd now probably say we're close enough to the edge that we're in good shape. All right, now let's try a negative number. -1. When you put your parentheses in there, make sure you put them around the negative sign. -1 squared is 1, and 1/2 of that is 0.5. So we're at positive 0.5. So -1, 0.5. What do you notice? Whoops, I graphed that wrong. What do you notice about that point right there? Look at the two of them. What are they to each other? They're symmetrical. So I'm going to make an assumption here. If those two are symmetrical, and we know this is a parabola, and we know parabolas are symmetrical, how far is this point right here that I'm pointing to away from the y-axis? It's 2. So go 2 away the other direction. I'm going to circle it because I didn't really plot that point using a table, Chris. I'm just anticipating it. Let's go up here. How far is this top point away from the y-axis? 3, so go 3 the other way. Make a symmetrical point there. And now let's draw our curve. When you get to the bottom of your curve, should it be a curve or a V? What do you think? It should be a curve. So try to make that bottom smooth, nice and gentle. Imagine a necklace hanging without a pendant. It's going to hang in a real gentle arc. And so there we have y equals 1/2 x squared. Let's compare that to a graphic, something done that's on actual calculator. Okay, here's 0.5 x squared. See if we can get that so you can see it. All right. And so here's what the graph looks like. Pretty close to ours in terms of shape. All right. Now, let's look at our next one. X squared minus 3. Let's start with our normal numbers, 0, 1, and 2. I picked those, Sophia, just because they're very simple numbers to try. All right, so 0 squared minus 3, 1 squared minus 3, 2 squared minus 3. Who can give me my first one? 0 squared minus 3. -3, thanks Caroline. So 0, -3. 1 squared minus 3, somebody else? -2. 2 squared minus 3. 1. Okay. So let's plot those. 1, 2, 3. 1, 2. Do I need another point? Do I need to try the point 3 in this case, do you think? I would. 3 squared minus 3. How much? 6. 3 comma 6. 1, 2, 3, 4, 5, 6. All right. Does it look like it's turning? All right, so let's try negative 1. I'll put it in red because it's negative. Negative 1 squared minus 3. Now I'm going to do this on my calculator. Negative 1. Okay, what do I need to make sure I do? Put it in parentheses. Negative 1 squared minus 3. Okay? So when you're doing that, you need to make sure you use parentheses on your calculator. Otherwise, it might give you the wrong answer. So, negative 2. What do you notice about that first red dot? What is it compared to the other side of the y-axis? It's symmetrical. So can I anticipate the other 2 points without plotting them? All right, so flip them over. Elliot, you see how I'm doing that? If it's 2 away there, it's 2 away on the other side. And if it's 3 away up here at the top, then it's going to be 3 away on the other side. And now draw your graph. Make sure when you get to the bottom of your graph, it's a curve. It's not a V. Now as we look at this, I want you to compare our 2 graphs. Forget about the fact one slid up and one slid down. I want you to look at their shape. And as we look at their shape, tell me about their shape in terms of narrowness, wideness. Which one would you say is the wider graph? The first one? Okay. Look at the equations. Forget about the minus 3. Look at the numbers in front of the x squareds. How many x squared is down here? 1. How many up there? 1/2. Any hypothesis? Let me show you some equations, and I want you to make some hypotheses for it. We're just going to do a little trial and error here, okay? I'm going to try to put this so we can see it, all right? Y equals. Let's make some estimations. Let's just start with x squared, and let's see what that looks like. Okay, there's x squared. Is that about as normal as you could be? Okay, now let's go to a different x squared. Give me a number. 6x squared. Let's compare. What happened? It got really skinny, didn't it? Okay. Give me a number besides 6. 2x squared. Was it as skinny as 6? Now that first one that's drawing is always what? X squared. That's kind of your standard.
Try negative 3.
Try negative 3. Okay. Negative 3x squared. There's our standard. Okay, 2 things happened. Describe what happened. First of all, what happened?
It flipped.
It flipped.
And it got skinny.
And it got skinnier. What caused the flip? The negative. What caused the skinniness? All right. How do I make it fat? How do I make it like a chip bowl?
I thought it would get fatter if we tried that.
Well, but it's a good hypothesis we're learning here. How can I make it to look like a chip bowl?
Negative x squared.
Negative x squared. Let's try that. Negative x squared. Whoops, delete the other x squared. There's positive x squared. Is it the same shape exactly? Just what? Flipped. Okay, I want to get it back to going up. How do I make it go up again? All right, so we need to make it positive. but I want to make it wide.
Positive 1/2.
Positive 1/2. Let's try that. 0.5 x squared. There's our normal, x squared.
Oh.
Okay, you just went from like a champagne glass to like, you know, a wine glass, but you didn't get that wide. I want a chip bowl. 1/4. All right, let's try 1/4. That's 0.25, right? I want my chip bowl. Okay, I'm still at kind of a fairly narrow glass.
0.1.
0.1. 1/16. That's 0.0. Oh, I'll just go 1/10. Let's see if we get our chip bowl now.
Oh no, that's too big.
Is that a chip bowl? Or maybe that's what the salsa would come in, right?
Yeah.
I'm really not at a chip bowl, am I? This is maybe a mixing bowl or whatever. I want something that's like really wide. How am I going to make something really wide?
0.01.
All right, 1/100th. Is that pretty low? Let's see. There's x squared.
Wow.
Now do we have our chip bowl?
No, it's a white.
Maybe a wedding platter, you know?
Watermelon.
Okay. Very, very, very gentle. All right, let's try 0.05 from Dylan. Now, 0.01 versus 0.05. Which one's,
Hey.
is this a little bit narrower? But not much, right? Okay, once again, x squared is our normal. 0.05.
There you go.
All right, that's probably a pretty good chip bowl. Can we have some chips? I wish. I wish. I will try to remember. All right, so what did we just learn about our numbers in front of the x squared?
They become food.
They become food. I don't quite think that was the goal. Now, 1/2. Let's kind of come back here. 1/2 x squared versus 1x squared. If I had you graph 10x squared on the graph here, what would the shape be? Very narrow. All right, now, another illustration. Come back to here. I want you guys to give me a prediction, and I'm going to change something else. Okay, and this kind of relates to the next idea on the next page. The next idea says, consider the changes when you graph the equation below. Now, we already graphed and changed the a. What happens when I change the number at the back? Let's watch what happens. Okay, here was our number that we did, x squared minus 3. Notice where x squared minus 3 is. It's normal shape, but where's the whole graph shifted? Down 3. So tell me your prediction for this. X squared plus 1. Okay. And is it up 1? Is it the same shape? It is. It may not look exactly the same because of the shift, but if you saw the two big graphs, you would see they are exactly the same shape. What else could I do to it? Let me take this graph. I'm going to delete this one. Tell me about this graph. Negative x squared plus 5. Give me a prediction.
It's going to be flipped.
Jess? Okay, it's going to be shifted up, but it's going to be
Upside down.
upside down. Let's see if Jess is right. Here we go. Is it shifted up? And is it flipped? Sophia?
Could you do like x cubed?
X cubed is called a cubic graph, and let me show you what it looks like. I need to change this to raised to the power of 3. I'll still do the plus 5, because that'll still push it up. But this is to the power of 3. It's a very different shape. It looks like an S. Completely different graph. That's not a quadratic. We're not going to do those this chapter, but it's a completely different graph. And so this gives us the chance to explore a little bit and do some stuff. So, just to kind of come back here, This number here, what does the number in front make it do? Okay, flipped upside down or not, wide or narrow. And what's the back number do?
Up or down.
Up or down. All right, so the width of a parabola is determined by the A value. The closer the number in front is to 0, Dylan, which one did you try? We tried what, 0.05? Okay, that was a nice wide graph. And 0.05, as an example, was pretty wide. That was Dylan's example. So the closer the number is to 0, the what the parabola is? The wider. Okay? The wider the parabola is. So I put some examples down here to kind of analyze. Let's look at the first column. Which of these 4 numbers is the widest parabola, and why do you say it's the widest? Dylan? Yeah, you're right. 1/8 is the widest. Why is it the widest? It's the smallest number. So let's put widest next to that, or number 1. So I would say that's our number 1. That is the widest. What's next in terms of wide? 1/3, okay. Wider. What about the 3 and the 21? The 3 is next. In general, would you call that wide or narrow? Yeah, I'd call it narrow. And then what do we do at the 21? Skinny? Really skinny. Really skinny. 21, that's really, really, really skinny.
Yeah.
Okay? 20, we want to take a look at it? 21. 21x squared. That's skinny.
That's me.
Okay? And in comparison,
Like 0.5.
there's 1/8.
Yeah.
That's, wow.
Okay, that's 1/8 compared to 21.
What would happen if we did like
That's
100 squared? Would it like,
100th
yeah,
x squared.
yeah, would it like flip? Would it, yeah, it would cross.
1 divided by 100.
No, 100.
No, 100
A 100x squared.
Sumo wrestler.
Give me a prediction.
It's gonna be a
It should be
sumo.
awesome.
Is it a flip or like?
It should be a straight line.
It's gonna be fat.
Did you see what happened? It was so narrow that a line just came down and went back up. It was incredibly narrow.
I'm so narrow, man.
So, all right. So we would hope that you would have a wide, open opinion about this and not be narrow-minded. Yes, Dylan.
How do you know if it's flipped or not? Like,
How do you know if it's flipped or not? Well, all of these are right side up. Now, over here, all of these have a negative inside, in front. So all of these
Oh, there's a
are upside down. Now let's look at these. Dylan did a great job of starting us off. Someone else start us off. Which of those is the widest?
oh, that.
Listen to what I'm asking. The widest. Chris? -1/2 is the widest. What's second widest? -3? I guess that's just second. -5 or -4? That's third. Now, why didn't I put wide on those words? Because are they really wide? The fact that they're a 3, a 4, and a 5, what are they really? They're really skinny. Okay. Does that make sense in terms of analyzing? All right, let's take a look down here. Tonight, we've got 12 problems, and I gave you graph paper